Hello and welcome to video 4 of the Angles video series. In this video we're looking at angles at a point. It will involve adjacent angles, and adjacent angles are beside each other. So let's draw a couple here. We've got the red angle and the blue angle there. And if you look carefully at those two angles, they share some things in common. That corner point for both those angles is the same point. The red angle meets at that point, and the two arms of the blue angle meet at that point as well. So we'd say that has a common vertex. Vertex is the name we call the point whereby the arms of an angle meet. So they have a common vertex. They share that vertex. And as we can see by the highlighted green arm there, we call that the arm of the angle. That's an arm on the top angle up here. It's an arm on that angle. And it's also an arm on that angle. And so they share that common arm there. So that's got a common arm. So that's adjacent angles. They're beside each other. It's a bit like your house and your next door neighbour's house. You share a common fence. So it's a bit like that. Okay, now there's some special ways that we can have adjacent angles sitting beside each other in some special sort of situations. So we'll have a look at each of those. Adjacent angles that make up a right angle, well, we'll know they add up to 90 degrees. So we've got a right angle here. We've got the right angle symbol in red down the bottom. Now if we cut that into two different angles there, we've got a top angle, which we will call x degrees. Let me draw in there. So that angle around to there, x degrees. And we've got the other angle, which we'll call y there. So that bottom angle is called y. Now we don't know much about the size of those angles, but we do know the sum of those two angles. We do know that x degrees plus y degrees make up that right angle, so that x degrees plus y degrees result is going to be 90 degrees. And we have a special name for two or more angles that add up to 90 degrees. We say that those angles are complementary angles. It's not that we can say nice things about them, give them compliments, but they're called complementary angles because they go together to make up 90 degrees. Another different situation where we have adjacent angles making up a different result here. Adjacent angles that make up a straight angle, they will add up to 180 degrees. So we saw that a straight line has it makes up a straight angle, 180 degrees. So if we split that up into two angles there, we've got a top angle and a bottom angle there, or a big angle and a smaller angle. They're sitting on that line there, so that smaller angle there, A degrees, and we could call the bigger angle B degrees. We don't know about their sizes so much, but we do know what they add up to. They definitely add up to 180 degrees. Now we had a special name for two angles that added up to 90 degrees. That was complementary. This time, two or more angles that add up to 180 degrees, we're going to call them a special name as well. They're called supplementary angles. So we could say there that the angles A and angle B are supplementary angles. Adjacent angles, they're beside each other, that make up one revolution. Well, they add up to 360 degrees. Now really it looks like just one angle here. It's an obtuse angle, perhaps you might be thinking. But you've actually got that top angle, and if you go all the way around, we could call that top angle N. But if we go all the long way around there, indicated by blue there, so can you see there's a small angle and a big angle really in this diagram. We'll call that bigger angle M. And we don't know much about the sizes again, but we do know what they add up to. Because it goes all the way around, m degrees plus n degrees will equal the whole 360 degrees. So it's 360 degrees from here all the way around. So we know that the red angle and the blue angle there must add up to that 360 degrees to make one full revolution. Okay, this is an interesting one. When two straight lines intersect, so when two lines cross, vertically opposite angles are formed. Special name, vertically opposite angles. So we've got the two lines there. They're crossing each other at that point of intersection. Let's consider that top angle, which we might call C degrees, and that bottom angle, which we might call D degrees. We can trust that C degrees equals D degrees, and we call them vertically opposite angles. So they're opposite on opposite sides of the diagram. Really, they're on opposite sides of that point of intersection, and we can say that they're equal to each other. Now we have the word vertically there, and these are kind of vertical. But we also have to check out a special, I guess, variation of that. I know we usually use the word vertical to go straight up and down, but in this case it's a bit more like they're just opposite angles. So let's have a look at this. We must make sure we realize or acknowledge that we have a left-hand side angle there too, which we could call A degrees. And if we compare that to the right-hand angle, B degrees, they're in a very similar situation to the C and the D. They're opposite the point of intersection. So we can be confident here, even though they're not really vertical, they're really horizontal, those two. A degrees, I'm here to tell you, does also equal B degrees in this situation. So they're not vertically opposite in terms of our normal understanding of the word vertical. So they don't go vertically, but they're certainly still equal to each other. So it's a bit funny, even A and B we could call vertically opposite angles, so be careful with that idea. Okay, so in this video we've had a look at adjacent angles and all the different situations where we can have angles beside each other making up 90 degrees or straight angles or revolutions, and we've had a good look at those. And we've also seen that adjacent angles have a common vertex and a common arm to them. Okay, we're called complementary angles. We've used that term. That's a special term for two or more angles that add up to 90 degrees. We've used the word supplementary angles, and we've used that for two or more angles that add up to 180 degrees. We've seen that you can have two or more angles that add up to one full revolution, so that'll add up to 360 degrees. And we've had a look at vertically opposite angles, and we've made ourselves aware of a special quirky thing whereby not only is it vertically opposite angles that are equal, but kind of horizontally opposite angles are equal as well. We don't really use that term, but just keep that in mind that the horizontal ones can be equal each other in that situation as well. So thanks for watching that video. We've learnt some important terms there to do with angles, and they'll help us solve problems in a couple of videos time when we know all our way around those special terms. In the next video we're going to have a look at some of the angles that are created by parallel lines when parallel lines are cut by another line. So that's some more angles we're going to learn about, and then we're going to solve some problems in the video after that. So thanks for watching. Remember, at any stage if you want to improve your maths, you can visit peterblakemaths.com for lots of great videos that will help your maths skills. Thanks a lot. See you next time. Bye.